Good morning, sir. Myself, Keerthi from CSM department, first year. My topic is about construction and working of hydrogen, oxygen, and methanol fuel cells. Fuel cells. Fuel cells are device which converts chemical energy directly into electrical energy. There are two types. First one is hydrogen oxygen fuel cell and second one is methanol fuel cell. Hydrogen oxygen fuel cell. The hydrogen oxygen fuel cells consist of an anode, a cathode and an electrolyte. First one, the anode is made up of a catalyst, typical platinum, and facilitates the oxidations of hydrogen oxygen. Second, the cathode is also made up of a catalyst, often platinum, and promotes the reduction of oxygen gas. The electrolyte allows for the ion exchange between the anode and the cathode. The separator prevents the mixing of reactant gases and allows the flow of electrons. Electron flow from the anode to the cathode through an external circuit, generating a usable electrical current. Here are the reactions of hydrogen oxygen fuel. First, anode hydrogen plus 2OH minus gives rise to 2 water molecules plus 4 electrons. Cathode oxygen plus 2 hydrogen plus 4 electrons, 4 OH minus. Net reaction, 2 hydrogen plus oxygen gives rise to 2 hydrogen oxygen. Working of the hydrogen oxygen fuel cell. At the cathode, hydrogen molecules split into protons and electrons. The proton passes through the electrolyte while the electron takes the external route. At the cathode, oxygen molecules O2 combines with the protons and electrons to form water molecules. The flow of electrons through an external circuit generates an electrical current. This process continuously as long as there is a supply of hydrogen and oxygen. Applications of hydrogen oxygen fuel cells. Hydrogen oxygen fuel cell find applications in diverse areas like transportation, portable device and stationary power generation. In the automotive industry, fuel cell vehicles offer zero emission operation and longer driving range compared to battery electric vehicles. Portable fuel cell provide a reliable source of power for camping, outdoor activities and emergency situations. Large-scale stationary fuel cells can be used for backup power, distributed generation and powering range location. The hydrogen oxygen fuel cells consist of an anode and cathode. Methanol fuel cells. The methanol fuel cell shares similarities with the hydrogen oxygen fuel cells but with some variations. The anode of methanol fuel cell utilizes a catalyst, usually platinum ruthenium, to promote the oxidation of methanol. The cathode remains the same, catalyzing the reduction of oxygen gas. The electrolyte allows for ion exchange, just like in the hydrogen-oxygen fuel cell. Overall, the constructions of methanol-oxygen fuel cells is similar to its hydrogen-oxygen counterpart. Here is the methanol reaction. Anode methanol plus 1 hydrogen gives rise to carbon dioxide plus 6 hydrogens plus 6 electrons. Cathode 3 by 2 oxygen plus 6 hydrogens plus 6 electrons gives rise to 3 water molecules. And redox reaction or net reaction, methanol plus 3 by 2 oxygen gives rise to carbon dioxide plus 2 water molecules. Here is the working rule of methanol fuel cell. In the methanol fuel cell, methanol is oxidized at the anode, production carbon dioxide, protons and electrons. The proton travel through the electrolyte while the electron transfers the electrical circuit. At the cathode, oxygen gas combines with the protons and electrons to form water. The generation of electrons through the external circuit result in the production of electrical energy. This process continues as long as there is a supply of methanol and oxygen. Methanol oxygen fuel cell advantages. Methanol oxygen fuel cells offers advantages in terms of fuel availability and excess of storage. Methanol is a liquid fuel that is more easily transportable and readily available than oxygen gas, hydrogen gas. The energy density of a methanol is higher than that of hydrogen, allowing for longer continuous operations. The use of methanol also simplifies the infrastructure required for the fuel cells adoption in various applications. Thank you for giving this opportunity.